Yes, good evening. So today's topic for us is structure, physical properties, and synthesis of cyanides and isocyanides. Cyanides and isocyanides. So what are cyanides? Cyanides are organic derivatives of hydrogen cyanide. Hydrogen cyanide is HC triple bond N, and it is a organic derivative of that, so we can represent it as RCN. This is called as cyanide. In the cyanide, if you observe, RC triple bond N is there, where one is the sigma bond and two are pi bond. Isocyanide will be RN double bond and C, where one is a coordinate bond. Now, cyanide and isocyanide, they are isomers of each other. And what isomer they are? They are structural isomer. Correct? So they are structural isomer. And what particular branch of structural isomer they are? They are functional group isomers. So what are functional group isomers? So functional group isomers is having a definition first, that of a isomer that having the same molecular formula but different structural formula. Correct? So structural isomer, but now we are adding to that functional group also. So that means they are having same molecular formula, different structural formula, and in the structural formula they have different functional group. Correct? So functional group difference will be there. So as we can already see, they have same molecular formula, but functional group are different. One is cyanide and one is isocyanide. Both of them, if the cyanide group and isocyanide group are placed separately, so we can call them as nucleophiles also. Nucleophiles are nucleus loving, so that means they have a lone pair of electrons with them. And since lone pair of electrons are present on the n side also in some cases and sometime on C, so they can be connected through both the sides. So when they are connected, that means they are donating the lone pair of electron from the nitrogen side. Then they are different nucleophile attachment, and when they are donating the lone pair of electron from the carbon side, then they are behaving differently. So they are called as ambident nucleophile. Ambident nucleophile. They are having a generally colorless nature and have a very smelly. Smelly means they have, so you can call cyanides are having a pleasant odor. But if you compare with them isocyanides, so they don't have a pleasant odor. They are having a very not a very good odor. We can call it as a unpleasant odor. And as you can see that carbon and nitrogen have different electronegativities. So due to the different electronegativities, we are observing that they are polar in nature. So polar, they are polar in nature. So here we are discussing their physical properties also. They are polar in nature. If they are polar in nature, they have high boiling points. Yes, because polarity leads to the higher intermolecular forces of attraction, and that leads to the higher boiling points. And if we observe their structure, we are observing that carbon is sp hybridized. And sp hybridized means they have a 180-degree bond angle. As the bond angle is 180-degree, so we can say that they are linear in structure. So they are linear. So we are talking about their polarity, we are talking about their boiling points, then we talk about their linear structure. Yes, they are linear in nature. And the isocyanides are linear also, and they are able to isomerize also, because they can show different type of a resonating structures. So I am representing those resonating structures like R and V. You can easily observe that a lone pair, one pair of electrons are here, and this is positively charged. So it has a triple bond, and one resonating structure will be like that, where N is having lone pair of electron and double bond with carbon and negative charge. So this molecule can also be behaving as, that means isocyanide can also be behaving as ambident nucleophile like cyanides also. And this is their resonating structures. So physical property and their boiling point depending, now they are because they are polar in nature, I said. So what is your advice? Are they soluble in water? So they are, even if they are soluble in water, they are again when the organic part is very small in size, like C1. But we can call them as a not a very much soluble in water. But if you talk about isocyanides, they are poisonous also in nature. And polarity is there, like if you compare them with the alkyl halides, so they are uh, better in that case. They are nitrogen and carbon are there, and electronegativity differences are there, but boiling points are not very high. Fine. So let us talk about their synthesis. So comparative studies should also be go side by side. Now, synthesis we generally do first from alkyl halides. Alkyl halides, you already know that alkyl halides also always are able to undergo nucleophilic substitution reactions, and order of reactivity is generally RCl, then RBr and Ri. Reason, you know that, because as the size is increasing, bond length is increasing, and as the bond length increasing, easy to break the bond, and then it become easy for them to be reactive or undergo nucleophilic substitution reaction. But here I am showing the reaction with uh, KCN, and what is happening here. So this bond is again breaking up, nucleophilic substitution, and we are getting RCN. So that means chlorine, bromine, iodine are able to leave the RCl bond, weaker bond, and RCN is a stronger bond. So that is why we are also talking about their boiling point, that their boiling points are little higher as compared to alkyl halides. Correct? So KCl will be formed, and simultaneously KBr and Ki will be formed. So this is about the synthesis from the alkyl halide. Now these are the synthesis of cyanides. So as I already mentioned, that cyanides and isocyanides are functional isomers. So that is why some of their preparation will be different from each other. Now next preparation is the preparation from amides. Amides we can take, again I am taking amide, C double bond O NH2, it is amide, lone pair of electron here, we can show that also to be more precise. And when the reaction is occurring with P2O5, it is a dehydration type of a reaction because oxygen and H2 will be lost, and we are getting RCN, again cyanide, and plus water. So it can also be called as a dehydration. Now, how to prepare the isocyanides? So the synthesis of isocyanides. So we should do that preparation by carbylamine test. So carbylamine reaction was a very good reaction, and it is forming the compound isocyanide. Isocyanide, we already know that during the Bhopal gas tragedy, where many people lost their eyes because of the poisonous nature of isocyanide, and it is the particular reaction that take place, that means due to the leaking of the gas from the bigger containers. So one is, this is primary amine. Okay, RNH2 is a primary amine. We can call it as a 1 degree amine also, and anyone you can take, reacting with CHCl3, and we are getting the compound RNCr and isocyanide. So yes, today we talked something about the preparation, little bit of physical properties, and synthesis of cyanides and isocyanide. Bye.